Hi guys. Okay, so today we're going to be talking about water and why water is such a special molecule and why it gives us, unique properties that we can use to survive on this planet. So water is made up of two hydrogen and one oxygen as a covalent bond between the oxygen and hydrogen, and a hydrogen bond that will connect other water molecules to itself. Now it is polar, and we'll talk about that more in a second, but it has a negative side and a more positive side. So, as I said before, two hydrogen, one oxygen. You might want to draw this figure in your notes. H2O is the other name for it. Now it is a polar molecule, and what this means is it's a molecule with a positively charged end and a negatively charged end. It's not entirely positive, it's not entirely negative, but it has a distinctly positive area and a very distinctly negative area. So our hydrogen atoms are positive, and our oxygen atom is the one with the negative charge. Now you can have nonpolar molecules which have a more balanced charge with the positive and negative, and there's not a distinctly positive or negative side. But water is not, it's polar. Okay. So water has a covalent bond because your oxygen has 6 electrons in its outer ring, but it wants 8, so it can be balanced and stable. So what it does is it borrows an electron from hydrogen, which only has 1 electron in its outer ring, and it wants 2 to feel balanced and stable. But then we only have 7 for oxygen, so we need another hydrogen. So that's where the second hydrogen comes in. It donates or shares its electron to complete that octet rule of having 8 electrons in your outer shell. So as a result, every 1 oxygen shares with 2 hydrogen, making a single molecule of water. So it's a covalent bond. They're sharing electrons. They go back and forth between the oxygen and hydrogen. Hydrogen does not give its electrons to oxygen. It shares them, and they both use them and need them to fulfill their outer shell. So just like we see here, hydrogen just hasn't given it away. It's sharing it with oxygen, these electrons right here. And then this is how the charge is distributed, because oxygen needs more electrons to fill its outer shell. So that's what gives it its negative charge over here. And since hydrogen is sharing it with over here, it has a more positive end over here, because this proton is left kind of towards the outside, and these electrons are brought towards the center to hold that water molecule together. Now there is also a hydrogen bond, and a hydrogen bond is an electromagnetic bond that's formed between 2 polar molecules. So here the hydrogen bond is connecting it to another water molecule. So we have another water molecule over here. It's connected from the hydrogen to the oxygen. Positive and negatives attract, and that's what's going to hold multiple water molecules together. Now, hydrogen bonding allows water to be attracted to other water molecules and other polar molecules. So this gives water one of its really unique properties in that it can bond with other polar things. It holds water together. It allows it to break and come back together, which we'll take a look at in a second. Now there are several other properties of water that we're going to walk through real quickly. Water is a solvent. It has cohesion, adhesion, high specific heat, vaporization, a high freezing point, and it also serves as a chemical buffer. Now, a solvent is a substance that dissolves other substances. So water is kind of a universal solvent. It can dissolve lots of other things because it's polar. And because those hydrogen bonds allow it to be attracted to other things, so it's able to dissolve them. If water was not attracted to those things, well, it wouldn't dissolve them. It would just kind of sit there. But water is a universal solvent. It can dissolve lots of different things because it's polar. It's going to try and bond with other things, which will break it apart and allow it to dissolve. Now, water is, well, there's hydrophilic molecules. Hydro means water, philic means loving. So hydrophilic means water loving. So there are some molecules that are water loving and are attracted to other water molecules. So hydrophilic molecules are polar with a positive and negative end, and they're going to form that hydrogen bond with water. So they want to bond with water. They want to be a part of it. Now, polar molecules interact really well with water, and so that's what makes it able to easily dissolve hydrophilic molecules because it wants to bond with them. It wants to interact. They want to form hydrogen bonds between them. Now, there are hydrophobic molecules. Hydro means water, phobic means fearing. So a water-fearing molecule is not going to bond with water. They are non-polar or they have a neutral charge. So they're going to keep away. That would be like oil and water. They don't dissolve. They just, oil will settle and it won't mix or blend with water. You can see those droplets separating out. It's going to try and keep away because it's not polar, so it cannot bond with water. So they don't form bonds with water, and instead they repel each other and they keep away from each other. So they cannot be dissolved by water. You would need another substance to be able to dissolve it. Now, cohesion is a pretty cool property of water. It causes water molecules to stick together to other water molecules. So what this does is cohesion causes surface tension. Now, because of these hydrogen bonds, your water molecules stick together. And what this cohesion is it makes them stick together, so then you get surface tension. And surface tension is a phenomenon that allows like insects to walk on water, water drops to form, and rocks skip across the pond because you have this tension or this, those bonds connecting each other to all the other water molecules. So let's see if I have another example. Yeah, so like right here, this paper clip, the reason it floats on top of the water is because water has cohesive properties. Those water molecules are sticking together, so it forms kind of like a net of molecules that allow things to stand on top of them. They have to be less dense than water, but that surface tension or that cohesion is what gives it water one of its unique properties. And like these water droplets, this is cohesion right here. It's sticking together. This water that's barely about to drip out over the edge of the graduated cylinder is another example of cohesion. Here's an example of surface tension. That's why the water smacks when you do a belly flop, is because you're hitting that surface tension with a lot of your force, and you can feel the impact of those bonds connecting each other in the water. This is called, I think, the Jesus lizard because it walks on water, because it's only able to do that because water has surface tension and cohesion and those hydrogen bonds that hold water molecules together. Now, adhesion is a property that causes water molecules to stick to other molecules. So what this does is it causes a capillary action. So water sticks to other things. That would be adhesion. Cohesion is when it sticks to itself. Co meaning together. Adhesion would be sticking to other things. Now, capillary action is a phenomenon where water in liquid causes it to spontaneously rise in a narrow space, such as a thin tube. Now, this can be kind of a tricky concept to get, so I'm going to show you another picture in a second. But basically, here I have a blob of water, and if I stick like a thin tube, like a straw or a capillary tube on top of it, what's going to happen is that water is going to rise up in there. And I'm not just going to get like a teeny bit that goes up in here and stays in here. I'm going to get the water sticks together. And so it sticks to other things, so it's going to stick to the sides of the capillary tube. It's going to stick to itself because of cohesion, and a lot of it's going to rise up the capillary tube or straw or whatever you're using. This is what allows water to defy gravity and reach the tops of the Amazonian canopies and those trees up there. This is how it gets so high, because it defies gravity, but that's because it's sticking to other things. It's slowly climbing up, the network of the xylem and phloem and getting up into the taller areas of the trees. And without this capillary action, trees would not be this tall. A lot of things would just work differently because this is a very unique property of water. They also use it like when they're drawing blood or running tests or whatever. This is a capillary tube, so if they get a drop of blood, you don't just have a little bit that like goes up here and sticks. Like it draws the blood up because it sticks to itself because that water in there, that's cohesion. It sticks to the sides of the capillary tube, which would be adhesion. Now, water also has a very high specific heat, and it requires a lot of energy just to increase its temperature 1 degree. So this is good for us, because if you can change temperature really quickly, well, if we go from a temperature of, like 97 to 120, that would be really uncomfortable and not good for you or for, the stability or homeostasis that your body needs to maintain. So for organisms, it means that their temperature will stay fairly constant in a wide range of weather. So for example, even during winter, rabbits can maintain a temperature of 101 degrees Fahrenheit, which is normal rabbit temperature. But if their temperature, dropped drastically, that would not be good for the rabbit. Also, because of this high specific heat, we can maintain our 98 degrees Fahrenheit regardless of how hot it is outside, even in the Sahara. So these people might be 120, 125 degrees out here, but these people can still remain, at 98 degrees Fahrenheit because it takes so much energy to change their inner body temperature, because water has that high specific heat that they're able to maintain that 98 degrees Fahrenheit, and they don't automatically just become whatever temperature is external to their body. So this also helps out with aquatic systems. It helps them maintain a stable temperature. Same thing for them. If their body temperature matched, their external temperature, that'd be, not always a good thing. But also there is a lot of stability in the temperature of water, which helps us maintain a more consistent temperature as a planet and for the fish that live in them. Now, vaporization, what this means is water absorbs a lot of heat before it evaporates. So that's why it makes water an excellent coolant, because it absorbs all that heat, and then once it evaporates, it wicks all that heat away and carries it away from you to make you feel cooler. So it absorbs a lot of heat before it evaporates. This is how evaporative coolers work also, is that they, gather up all this heat, and when it evaporates, it takes away all that heat. Now, water also has a high freezing point, which means it freezes at a relatively high temperature. So this is great for animals who live in ponds and lakes in places like Alaska and Wisconsin and the poles. So when water freezes, it becomes less dense than liquid water and therefore floats on top. So it becomes less dense water, it begins to float on top. If water froze at a different temperature, would it change a lot of ecosystems, and life would not be possible in, specific areas or ecosystems. So what this means is that ice covers the tops of the lakes, rivers, ponds, and streams, and it insulates and protects the organisms below. So because this water, it freezes at a relatively high temperature and it floats on top, what this does is it allows the temperature below the ice to maintain a more stable temperature, and so organisms can still live below them. So it's not like everything dies in the winter because it gets too cold. Now, water also serves as a chemical buffer because it provides the perfect environment for reactions to take place because it's neutral. It has a pH of 7, so it's not acidic, it's not basic, it has a pH of 7, so it's neutral. So this is a perfect area for other interactions or reactions to take place, and that's a big part of what gives us life. Water is where many biomolecules are able to form and react, which created life, such as this.